Hello everybody, welcome to another part of the OpenThread 101 series, and in this video we will talk about the UDP command that is included in the OpenThread CLI. So UDP is user datagram protocol, and it's extensively used in OpenThread. One of the reasons is because UDP has less overhead. There is no retransmission of packets, or there are no acknowledgements as well, so it causes less packets to be sent um, compared to TCP, where each packet has to be acknowledged as well, and if the packet is not being acknowledged, then the sender is going to send it again, and that can cause network congestions for a low power, low bandwidth network like OpenThread. So that's why in OpenThread we have applications like CoApp and MQTT-SN that are based on UDP. So the normal MQTT is using TCP, but the MQTT-SN, I guess the sense SN is for censored network, is based on UDP, and CoApp is also based on UDP. And just like I said, OpenThread CLI provides UDP command to send and receive UDP packet. So we will have a look at that. First, let's go to the CLI reference and open the OpenThread CLI UDP example. So here you can find the documentation on how to use this. So we will just follow this along, and we'll show you how it works. So let's open Visual Studio Code, and I will turn on my development boards so that we can have two devices that can talk to each other. And so now both of these devices are online, or not online, but connected. So let's connect to their UARTs. So that's the UART for device 1, and then this is the UART for device 2. I would move them into new windows so that it's easier for you guys to see. So device 1, we have OT state disabled. Device 2, OT state disabled. So first we will check the data set on these devices. So it is correct. So we would bring up the interface, and then we would do is start the thread network, and we check it using OT state now. So in a while it should have, then this is the first device to start, so this should have the leader role. So we would enter it a few more times. It usually takes a few seconds. So now you can see here that this device is the leader. So I would type clear to clear the terminal, and then OT IP address to check the IP address of our device. So here is our link local IP address. This one is a mesh local address. So this would work even if the devices are not within direct range, but there are maybe some routers in between, and then we would have to use these addresses. Normally we would use the mesh local address, but for now let's use this one. Then we set up the network on the second device as well. So let's check the data set. So it is working, it is set. So we would do is OT ifconfig up, and then OT thread start to start the network. And now we would check with OT state to see when the device is online. So check it again. Still detached. Maybe a few more seconds. Still detached. Device is now router. So if we do, let's clear it, and then we do OT IP address, and that is the local address of this link local address of this device. We have the link local address of this device. This is the mesh local address for this device. Here is the mesh local address for this device. These two addresses are called locator addresses. So this one is called route locator, and this one is anycast locator. But for now, we would not go too much into details. And here we have the route locator here as well. And here we don't have the anycast locator. And how you know why these are the locators? So here, basically this 0FFFE00 is the telltale of these locator addresses. Now we have our devices online. We can ping them. So let's copy this address and type ping from here. So we will do OT ping, and it was able to ping it. So packet launch is 0%. And now let's go back to the UDP example. So on the receiving side, we would have to do a UDP open, and then a bind. Basically, the server would start listening on this port. So, and this is a 00, so it will listen on. It will listen to all IP addresses on this port. So let's do that. So on device 2, we would do OT UDP open, then OT UDP bind, and then this you would copy it. OT UDP bind, and then any address or all addresses, and then this is 123 is the port. So our device 2 is now listening on this port. So here on device 1, we would have to do UDP open again. So that was the wrong tab. So we will do OT UDP open, and then we would send the command. So we would copy this and just prepend it with OP. So OP UDP send, and here if you look, they seem to be using the mesh local address, but for now we would use the link local address. So here's our link local address. So you copy it here, we would paste it here, and once we send it, you should see hello being received on the other side. So if I type enter here, it says done, and on this side it says 5 bytes received from our IP address, and then the bytes are hello. Let's try the mesh local address as well. So if we press up the up key and replace the link local address with the mesh local address and type enter, it will say done. So basically send the command, and here now the address, the source was the mesh local address of our device. So this is how it works. I don't know if the source can also be the link local address and the destination can be mesh local address. Probably possible, but that's how it is implemented in the CLI for now. And this is how you would send UDP packets from one device to another, and this CLI provides for that, and we can use this during our tests. I think this is enough for this video. In the next video, I will show you how to sniff this traffic using Wireshark so that you can look into the different types of packets and see what's going on, what kind of packets are being sent in the background when these devices join network and when they are talking to each other. So I hope this video was useful, and see you in the next one. Thank you.